Hello everyone, this is Akshara of CSC AML A section. Today I am going to talk about Schur complement of M matrices. What is Schur complements, what is M matrix and what is Schur complement of M matrix, its properties and applications. Let's get into introduction. Introduction. Schur complements are matrices that are used in linear algebra and matrix theory. They are a direct parallel method that can be used to solve phased linear equation systems. M matrices. In mathematics, especially linear algebra, an M matrix is a matrix whose of diagonal entries are less than or equal to 0 and whose eigenvalues have non-negative real parts. An n into n real matrix M is considered an M matrix if it satisfies one or more of the following equivalent conditions. Non-positive off diagonal elements. M row into column is greater than equal to 0 for all I is not equal to j. Positive stability. All eigenvalues of M have positive real parts. Inverse positivity. M is invertible and M inverse is greater than 0. All elements of M inverse are non-negative. What is M matrix? Alexander Ostrovsky is thought to have named M matrix after Hermann Minkowski. And matrix is considered as an M matrix if it meets the following properties: non-negative diagonal dominance, positive inverse condition. Each diagonal entry is larger in magnitude than the sum of the magnitude of diagonal entries in the same row. Inverse condition. A matrix is also classified as an M matrix if it has an inverse that is non-negative, which is equivalent to saying that the matrix is invertible and monotone. Properties: stability, non-singularity, applications in linear systems. Stability. The eigenvalues of M matrix often have non-negative real parts, which is useful in stability analysis. Singularity. If it is an M matrix, it is often non-singular, meaning it has non-zero determinant. Equivalent condition. Equivalent condition of M matrices. There are many equivalent conditions for non-singular M matrices, including positivity of principal minus, inverse positivity, splitting, stability and semi-positivity and diagonal dominance. All of diagonal entries are non-positive and the matrix is invertible with non-negative inverse. The principal minors of the matrix are positive. Here is an example for M matrix: 4 minus 1 minus 2 minus 1 3 minus 1 minus 2 minus 1 5. All of diagonal entries are non-positive and the diagonal entries are positive. M matrix have several interesting properties including non-singularity. Now let us talk about introduction to Schur complements. Introduction to Schur complements. Schur complement was named after Isai Schur. Emily Virginia Highsworth was the first to call it as Schur complement in 1968. The Schur complement of M matrix is a mathematical tool that's used in many areas of matrix analysis. It's defined as a result of a block Gaussian elimination on a matrix and appears in the upper left block of the matrix. The Schur complement can be used to solve linear systems, derive matrix inequalities and many more. Schur complement is a linear algebra technique that is important in many of mathematical applications including computational mathematics, numerical analysis, statistics, solving large problems. The Schur complement is a key part of computational mathematics and control theory. The Scotch complement is an important tool in numerical analysis. Scotch complement is used to solve large problems on hundreds of processors. Now let's start discuss about the conditions of Scotch complement. Conditions for the Scotch complement of matrix are that the block A and D of the block matrix M must be square matrices. The Scotch complement is defined as follows. If D is invertible, then the Scotch complement of D of the matrix M is P by P matrix defined by A minus B into D inverse into C. If A is invertible, then the Scotch complement of the block A of the matrix M is the P by P matrix defined by D into C into A inverse into B. If A or D is singular, the generalized Scotch complement can be obtained by substituting a generalized inverse for the inverse on M by A and M by D. Properties of Scotch complement in M matrix. Monotonicity. This property for the Scotch complement of positive semi-definite matrices is well known. A monotonic function is a function that preserves or reverses the order between order sets. The concept of a monotonic function originated in calculus and was later generalized to order theory. Monotonicity in other words, as we consider large principal submatrices, the Scotch complement value decreases in component wise sense. Positivity preservations. If a matrix is M matrix, then the Scotch complement is given as A22 minus A21 into A11 into A12 is also M matrix under the following conditions: non-singularity of A11 and positive definite exists. If A11 is non-singular, then the Scotch complement S is well defined and is also an M matrix. This is due to the fact that the M matrix properties are preserved in the Scotch complement process. For M matrix A, if A is also positive definite, then the Scotch complement of S is positive definite as well. This positive definite is a result of the fact that being an M matrix implies that all the principal submatrices of A including S, the condition need for positive including S is the condition of positive definite. Now let's talk about the condition for invertibility. For a Scotch complement to be inverted, it satisfies the condition of non-singularity of A and non-singularity of A11. If A is non-singular, then its Scotch complement S is also guaranteed to be non-singular. For S to be well defined, the principal submatrix A11 itself must be invertible. If A11 is not invertible, then A inverse does not exist and S cannot be computed in this form. Therefore, assuming A is a matrix and A11 is invertible, S will be also invertible. Let us discuss some applications regarding Scotch complement of M matrix. Applications. The Scotch complement is a mathematical tool that has many applications including the study of M matrix, inverting and factoring block matrices, computing inertias, computing covariance matrices, inverting and factoring block matrices. A Scotch complement calculator can be used to derive formulas for inverting and factoring block matrices. Computing inertias. The Scotch complement's properties can be used to compute the inertias of matrices. Computing covariance matrices. The Scotch complement's properties can be used to compute covariance matrices of conditional distributions. Here is an example and calculation regarding Scotch complement of matrix. Given a matrix 3 minus 1 minus 1 minus 1 4 minus 1 minus 1 minus 1 3. So let's compute the Scotch complement of the top left 2 by 2 block. A is equals to 3 minus 1 minus 1 4. B is equals to minus 1 minus 1. C is equals to minus 1 minus 1 and D is equals to 3. Let us find A inverse firstly. A inverse is equals to 1 by 11 into 4 1 1 3. Now we can calculate the Scotch complement using the formula D minus A C into A inverse into B. Then the Scotch complement of the given matrix is 26. Summary. In summary, M matrices are a class of matrices with specific properties that are important in many fields, them valuable in various mathematical and engineering applications. Understanding their characteristics and applications can be useful in many areas of study. Scotch complement of matrix remains an M matrix when the following conditions are met. Invertible box. If the blocks A and D in matrix M are invertible, then the Scotch complement of A and D are also M matrices. Generalized Scotch complement. If A or D is singular, then the generalized Scotch complement can be used. This is done by substituting a generalized inverse for the inverse on M by A and M by D. Thank you.